Okay, so quick review from the last video. For the next several months, we're going to be talking about derivatives. A derivative is the slope of a function at an instantaneous point. Now, up to this point, you've calculated slope a lot, but it's always been over an interval, y2 minus y1. This is doing slope at a single point. The equation for that is this, which is what we came up with in the last video. Now we want to talk about applying that equation, so actually calculating derivatives of a function. So let's do this first example. If f of x equals this, I want to find f, by the way, this is called f prime of x, and it just stands for derivative. So I want to find the derivative. That means, if I go back up to my my definition right up here, I need to find f of x plus delta x. I need f of x, and then I always have delta x in the denominator. So f of x plus delta x, that means plug this in for x there. So then I've got x plus delta x squared plus 2. So I'm plugging all that in for x. Then my f of x is x squared plus 2. Now, back to our definition. We need to take that first one minus that second one. So I've got x plus delta x squared plus 2 minus x squared plus 2. The first one minus the second one. Now, let's start to simplify this. So I have the limit as delta x goes to 0. So first thing I want to do is FOIL this part out. So this is going to be x plus delta x times x plus delta x. That's squaring it, plus 2. And then I also want to distribute my negative. So minus x squared minus 2. All over delta x. Okay, let's continue to simplify by FOILing that square. So I get x times x, which is x squared. X times delta x, which is x delta x. And then delta x times x, so I get x delta x again. And then delta x times delta x, which is delta x squared. Plus 2 minus x squared minus 2. Okay, let's simplify this some more, combine some like terms. So I have an x squared minus an x squared. So that's going to go away. I have an x delta x plus an x delta x, so that's going to be 2 x delta x's. Then I have a plus delta x squared, which can't be combined with anything. And then I have a plus 2 minus 2. So those are going to go away. Hey, this just got way simpler. All over delta x. Now, what does the top have in common that I can take out? Well, if I look at it, that numerator, they both have a delta x in common. So I'm going to take that delta x out. GCF, greatest common factor. So then that way, I have top and bottom cancel, which is a good thing. Almost done. I'm going to rewrite this one more time. And I'm left with 2x plus delta x. Now we're finally to a limit problem. This is exactly what we had last chapter, where remember with limits, the first thing we try is direct substitution and see if it works. If we have problems from there, then we can start to do other things. But with a limit, I'm just going to substitute 0 in for delta x. So I have f prime of x equals 2x plus 0. So f prime of x equals 2x. So 2x would be the derivative of x squared plus 2. Now, I know that was a lot, but now we can start to use this where we can apply our derivative. So it says use your answer from part A to find f prime of negative 3. So if I want to find f prime of negative 3, I just need to plug negative 3 in to f prime. So f prime of negative 3 is going to be negative 6. Now let's talk about what that means. So that means at x equals negative 3, the slope of x squared plus 2 is negative 6. Exactly. So at that point, the slope of the function is negative 6. That's what this derivative is telling you. The instantaneous slope at a single point. Okay, in the next video, we're going to try another example where we apply this limit definition.